All right, in this video, we're going to look at graphing linear equations using tables. 2.1 video sheet would be handy and a pencil. All right, so on your video sheet, you have 6 graphs with tables next to them. We're going to start with this first one, and every time you're going to see an equation, and that equation forms a relationship between y and x. And in this first slide, we're just saying that y equals x. So no matter what x is, so I'm just going to pick some arbitrary values for x. I'm just going to go from -2 to +2 by ones. So I'm not going to use the whole table. I could easily put another value down here, but I'm just going to use these 5 inputs. So if y equals x, no matter what x is, y is the same value. So when I plug in, for example, -2 for x right here, it makes y equal -2 as well. So y is equal to the x value. That looks like a decimal. Let me get rid of that. All the way down the table is going to be a mirror image. The y values will just equal the x values. So when we go to plot these, we're just going to plot these as points. -2, -2, -1, -1, 0, 0, 1, 1, and 2, 2. So no matter what value I plug in, I can keep going forever. 5, 5, 10, 10. It's always going to fall on this line. So this straight line goes on forever, indicates all the values where y is equal to x. All right, so that's a basic one to get started. Sometimes we call this the parent function of all linear functions where y equals x. We call that the parent function. All right, so we're going to see what happens when we change the equation slightly now. So this time, no matter what the x value is, we're going to double it. So I'm going to go through and do the same inputs. So if you want to try this on your own, you could copy these inputs down, pause the video right now, copy these inputs down, and try to plug them in and get the y values and plot the points. I'll give you a start. If you want to pause the video after you see the first one done, you can do that too. All right, so if I plug in -2 for x right here, I'm just going to double it. So 2 times -2 is -4. And I'm just going to keep doubling every one of these. -1 times 2 is -2. So we're saying that y equals twice the value of x. So we just keep doubling every single time. All right, so we go to plot those points. We get -2, -4, -1, -2, 0, 0, 1, 2, and 2, 4. So that's what your line looks like. It keeps going up like that. Now, one thing to notice that we'll talk about later is that the difference between the last slide and this slide was we put a multiplier in there. We call that number the slope. So this multiplier in front of x is changing the graph by making it steeper. So if you notice, it's going up 2 over 1. So this line is steeper than the last one. I don't want to get into too much detail right now, but let's see what the next one looks like. All right, so this one, same inputs. I'm typically going to use -2 through +2 just as the main 5 inputs for this. All right, so this time we're going to take the negative value of x, or -1 times x. So no matter what x is, we're going to kind of multiply it by -1, or you can think about it as taking the opposite sign of x. So y equals the opposite sign of x, -x. So -2 is +2. -1. So this is what we're doing here. So y equals -2, which is +2 for the first one. And we keep doing that all the way down. -0 is still 0. When I plug in 1, it's -1. And when I plug in 2, it's -2. So when I plot these, we see that it kind of takes that parent function from the first graph and it flips it. We call this a vertical flip. It kind of, the slope is now negative, so it's sloping downward instead of upward. So that's something we'll talk more about later. All right, let's move on to the next one. Let's see what when we add a value to x, how that affects the graph. So again, let's plug in -2 through +2. If you want to try these on your own, you can pause the video right now and do that. Might be a good idea to try this. All right, so on this one, we are plugging in these values. So -2 plus 3. So all we're going to do is add 3 to each one of these 5 values. -2 plus 3 is 1. -1 plus 3 is 2. So all I'm doing is adding 3 to the x value to get the y value. All right, that's all there is to it. So you plot these points, -2, comma 1, -1, 2, 0, 3, 1, 4, and 2, 5. So you may notice that we get another straight line. And if we compare this to the original parent function, I'm just going to draw the parent function in red here. The original function on our first slide, if I copy that one down here, that's not a very straight line. If I copy that one here, notice what happens is we take this red line, if I click on it, and I go up 3, 1, 2, 3, it turns into the blue line. So that +3 has the effect of an upward shift of 3. All right, so we call that the y-intercept. We'll talk more about that later, but I just wanted you to notice in this slide that what effect that's having on the equation. We'll put all that together in some later videos. All right, so this one's slightly more advanced. It looks like we have an upward shift of 3 again. All right, so we kind of probably are going to guess that something's going to happen where it's going to move up 3, but then we also have a fractional slope. So why don't we just go ahead and plug in some numbers. This time I'm not going to plug in the ones I've been plugging in. I'm going to choose some nicer inputs. I can see that I'm going to be multiplying by a half. So I'm going to use numbers that are even. So instead of -2, -1, 0, 1, 2, I'm going to do -4, -2, 0, 2, and 4. And I'm doing those because the outputs will be a little bit nicer. So if you want to pause the video right now and see if you're getting the hang of this, all you're going to do is take 1/2 of the x value and then add 3 to it. All right, so if you want to pause the video and try this table and make the graph, that would be a good idea. All right, if you're back, I'm assuming you tried it. So this first one is -2 plus 3, which is 1. -2 times a half, so I'm doing the next one now. -2 times a half is -1 plus 3 is 2. 0 times a half is 0 plus 3. We're starting to see a pattern here. Wonder if this pattern is going to continue. We'll see. 2 times a half is 1 plus 3 is 4. Looks like it is. 4 times a half is 2 plus 3 is 5. So when I plot these points, I need to be careful. -4, 1 is here. -2, 2 is here. And I'm just going to finish this off. And there's your line. Now, two things to notice. Again, if I look at the parent function, which I will graph very quickly, y equals x, the very first one we graphed, two things happened. We shifted it up 3, but then if you look, it's not as steep as it used to be. That's because we multiplied it by a half. So the new slope, you actually learned a little bit about slope in Math 7. The slope of this blue line is up 1 over 2. 1 over 2, which is 1/2. So it's half as steep because of that multiplier. We call that the slope again. So 1/2 x plus 3. So in the next video, we're going to graph these without even using a table. So I'm kind of giving you an introduction to that by talking about some of these concepts. All right, let's look at the last one. I put this one in here because it's somewhat trivial. I'm going to do the standard 5 inputs. The problem is that we're saying that y equals -3. And we're not saying that this is different than this. We're not saying to multiply by -3. We're actually saying that no matter what x is, y is -3. So we're not really plugging in the x values this time. This is kind of a trivial situation that I wanted to show you in this slideshow. No matter what I do, y is -3. All right, so it's a constant. So when I plot these, I just get a straight line. No matter what x is, y is -3, and that gives us a horizontal line. The slope of this line is 0. And I don't want to get into too much detail on that in this video. We'll talk more about that later. But this is kind of a trivial situation that you'll start to get used to seeing. You know what? I don't know why I graphed that at +3. This should be at -3. Talked too much and I lost track of what I was doing. All right, so that's our line right there at -3. Makes more sense now. All right, I hope this video helped. All we're doing here is graphing linear equations using tables to help us. In the next slideshow, next video, we will move away from tables. All right, hope it helped. We will see you next time.